Burj Al Arab looks like a giant sail floating above the water. But the wildest part is not the gold inside, the helipad in the sky, or the fact that it rises 321 meters. The real problem was underneath it. There was no land, no nearby bedrock, no solid foundation waiting to be used, just open sea and loose sand that could never hold a building this heavy on its own. Before the first floor could go up, 2,000 workers had to create an island from scratch. They drove 230 concrete piles into the seabed and somehow made the sand grip the entire structure. The project cost $1 billion and took 5 years. One bad calculation in the piles, the concrete, or the wave protection could have sent the whole dream underwater. So how do you build a skyscraper in the sea when you cannot even reach solid rock? Everything started with one simple idea. Dubai didn't just want another luxury hotel. They wanted one building that people would recognize instantly, something that would make the whole world think of Dubai the moment they saw it. That idea became the Burj Al Arab, shaped like the sail of a traditional Arabian dhow. It looked simple on paper. Building it was anything but simple. The chosen site sat about 280 meters off the beach. At first, there was nothing there. No island, no solid ground. Just open water stretching in every direction. Before anyone could even think about pouring concrete or raising steel, they had to solve one huge problem. They needed land where no land existed. The first step was driving 230 massive concrete piles into the seabed. Each one was about 40 meters long and 1.5 meters wide. Normally, a building this size would be anchored into bedrock. That wasn't possible here. The bedrock was more than 180 meters below the surface, far too deep to reach without turning the project into something completely different. So the engineers came up with another solution. Instead of resting on rock, every pile would grip the surrounding sand through friction. It sounds risky at first, but when it's designed correctly, the sand itself becomes part of the foundation. The strength doesn't come from hitting solid rock. It comes from thousands of square feet of contact between the piles and the compacted sand around them. Once the piles were in place, temporary steel sheet walls surrounded the entire construction area. Those walls acted like a giant barrier, holding back the sea while workers slowly built the island inside. Then came one of the most unusual parts of the whole project. They pumped a mixture of sand and water into the enclosed space. Little by little, the water was pushed out, and new ground started taking shape where there had only been open sea. But fresh sand isn't strong enough to support a skyscraper. It had to be compressed until it became dense and stable. Every section was carefully tested before the next stage could begin. Around the edges, huge armor rocks and specially designed concrete honeycomb blocks were installed. Instead of fighting every wave head-on, they absorbed and spread out the wave energy, protecting the new island from constant erosion. After years of work, the artificial island finally stood about 7.5 meters above sea level. For the first time, the workers weren't standing in the ocean anymore. They were standing on land they had created themselves. Sometimes the biggest obstacle isn't the project itself, it's the environment around it. And before you can build something extraordinary, you may have to create the place where it can even begin. Once the island was finally ready, the hardest part still wasn't over. Now they had to build a foundation that could hold the entire hotel for decades, and there was almost no room for error. The first job was trimming every one of the 230 pile heads to exactly the same height. The tolerance was only about 5 millimeters. That might not sound like much, but if one pile sat even slightly higher or lower than the others, the weight wouldn't be shared evenly. Over time, that tiny mistake could become a very big problem. After that, workers poured a thin layer of concrete across the entire site to create a perfectly level surface. Then, they covered everything with a waterproof membrane. It wasn't there for looks. It was there to stop seawater from pushing up through the foundation for the next 100 years. Next came the steel. Thousands of reinforcing bars were tied together by hand until they formed one massive cage. Every pile was connected into the raft foundation, so instead of carrying weight on its own, all 230 piles worked together as one system. The goal wasn't just to make the foundation strong, it was to spread the load as evenly as possible. Then came one of the biggest concrete pours of the entire project. Around 70,000 cubic meters of concrete had to be placed without stopping. That part was critical. If the pour stopped for too long, the concrete could form what's called a cold joint. That weak line would stay inside the foundation forever. As the concrete was poured, workers used vibration equipment to remove trapped air. Even small air pockets could weaken the structure. At the same time, cooling pipes were built into the foundation because concrete generates a surprising amount of heat while it cures. If the inside became too hot, it could crack before anyone even noticed. The temperature was checked constantly. The surface was kept wet for weeks so the concrete wouldn't dry too fast and shrink unevenly. Every step was slow, controlled, and carefully monitored. There was no shortcut. Most people look at Burj Al Arab and notice the sail shape or the luxury inside. Almost nobody thinks about what's buried underneath. But that's really where the story begins. The strongest buildings aren't famous because of what people can see. They're strong because of the countless small mistakes the builders refused to let happen. With the foundation finally complete, the hotel could start rising. But even this part wasn't about building as fast as possible. It was about repeating the same process over and over until every floor was exactly right. The first thing to go up was the concrete core. Instead of surrounding the whole building with scaffolding, the crew used a self-climbing formwork system. After each section of concrete hardened, the forms lifted themselves to the next level. The building almost seemed to grow on its own. The floors were built using post-tensioned concrete. Before each slab was poured, workers threaded long steel cables through ducts already placed inside the concrete. Once the concrete gained enough strength, those cables were pulled tight. That constant tension kept the concrete compressed, making each floor stronger while using less material. Then, everything started to follow a rhythm. Pour the concrete, wait for it to cure, stress the cables, remove the forms, lift them to the next floor. Then, do it all again. That same cycle happened 56 times. It wasn't exciting work. It was careful, repetitive, and incredibly precise. But that's exactly how projects like this stay on schedule without sacrificing quality. The team also had to think far ahead. Steel anchor plates for the massive exterior frame were cast directly into the concrete core. Pipes, electrical conduits, and mechanical openings were built into the walls before the concrete was poured. Nothing was left until later. Cutting into finished concrete would only weaken the structure and slow everything down. Floor after floor, the tower climbed higher above the gulf. Eventually, the concrete core reached its full height of 321 meters. By then, the shape of the building was already easy to recognize. But something was still missing. The famous white sail that people associate with Burj Al Arab wasn't there yet. At this stage, it was just a giant concrete tower waiting for its outer structure to give it the look the world would remember. Watching this process, you realize something important. Massive projects don't move forward because of one brilliant moment. They move forward because the same small steps are repeated with discipline, day after day, until something impossible slowly becomes real. Once the concrete core was finished, it was finally time to build the part everyone would recognize. But here's something most people never realize. That giant steel frame on the outside wasn't added just to make the hotel look beautiful. It was a major part of the structure itself. About 9,000 tons of structural steel arrived at the site by barge. Piece by piece, workers lifted every beam into place and connected it to the anchor plates that had been built into the concrete core weeks earlier. Every bolt had to be tightened to the exact specification. There was no guessing. Every connection mattered, because every connection would eventually carry real loads. As the frame grew taller, diagonal cross braces were installed across the structure. Those braces gave the building the stiffness it needed to stand up against the powerful Gulf winds. At that height, the wind never really stops. It pushes on the building every single day. The steel frame wasn't decoration. It was helping the entire tower stay stable. The work itself was just as incredible. Crews climbed the outside of the structure with nothing but steel beneath their feet and the ocean far below. There were no shortcuts. Every beam, every brace, and every bolt had to fit exactly where it belonged. Then came one of the most challenging sections of the entire project. The Al Muntaha restaurant was built, extending about 27 meters out from the side of the tower. That wasn't just empty space. The structure had to support the restaurant itself, all the equipment inside, and every guest who would eventually walk through its doors. Not long after that, workers assembled the famous helipad, about 210 meters above the water. Standing there was nothing underneath except open sea. By the time the last pieces of structural steel reached the top, the building looked impressive, but it still wasn't complete. The iconic white sail hadn't been installed yet. One thing became very clear during this stage. If you removed that exterior steel frame, the concrete core alone wasn't designed to handle all the wind forces from the Gulf. The outside frame wasn't just part of the design. It was one of the reasons the building could stand there in the first place. With the steel frame finally in place, the building still didn't look like the Burj Al Arab people know today. It was strong, but it hadn't found its identity yet. That changed when the famous white sail started going up. The material wasn't ordinary fabric. It was woven fiberglass coated with PTFE on both sides. It had to survive blazing heat, salty sea air, and years of constant sunlight without breaking down. Every single panel was custom-made because the building curves from top to bottom. No two sections were exactly the same. Installing those panels took just as much precision as building the structure underneath. Workers stretched each one into place using cables and turnbuckles until the surface was perfectly tight. That mattered more than most people realize. If a panel was even slightly loose, the Gulf winds could make it flap over and over again. Eventually, that movement would wear the material out. The atrium used a double-layer membrane that faced north. That wasn't just a design choice. It helped block harsh direct sunlight while still filling the massive interior with soft natural light. During the day, the white surface reflected sunlight and gave the building its clean, bright look. At night, light from inside passed through the membrane, turning the entire hotel into what looked like a glowing sail floating above the sea. That's probably my favorite part of this project. One material was doing 3 jobs at once. It created one of the most recognizable skylines in the world. It controlled light inside the building, and it stood up to one of the harshest coastal environments year after year. That's smart engineering. When one solution solves several problems at the same time, you've probably found the right design. Once the structure was finished, the project entered a completely different stage. This wasn't about making the building taller anymore. It was about turning an engineering project into one of the most recognizable hotels in the world. The first thing that catches your eye inside is the massive atrium. It's about 180 meters tall, and even standing at the bottom, it feels more like you're inside a giant canyon than a hotel. To make that space work, crews installed the rails for the glass elevators with incredible precision. Every lift had to move smoothly from the lobby all the way to the upper floors before a single guest could step inside. Then came the details people actually notice. Gold leaf was carefully applied to the columns by hand. Large slabs of Carrara marble were installed throughout the lobby, with workers matching the natural stone patterns from one piece to the next. It wasn't enough for the marble to fit. It had to look like it had always been one continuous surface. The hotel included 202 duplex suites, and almost every room had something unique about it. Many of the curved ceiling sections were prefabricated off-site before being installed. Thick acrylic panels were fitted into the giant aquarium, while custom carpets from different countries were measured, trimmed, and installed by hand. Nothing was treated like a standard hotel room. Even the restaurant high above the sea had to be finished in an unusual way. Heavy kitchen equipment was lifted nearly 200 meters into the air before it could be installed. Every piece had to be secured, so nothing could shift once the building was operating. Before the hotel could open, every system had to prove it worked. The glass elevators were tested through their full travel. The fountain in the atrium was adjusted until the water reached exactly the right height. A bridge nearly 280 meters long finally connected the island to the mainland. Fire sprinklers, smoke dampers, electrical systems, and mechanical equipment were all inspected one by one. Nothing was left to chance. The last step wasn't glamorous at all. Workers cleaned the exterior from top to bottom, inspected every room, and fixed thousands of small issues before opening day. On the 1st of December 1999, the doors finally opened. Most visitors walk in and remember the gold, the marble, and the luxury. But what they never see are the thousands of measurements, inspections, adjustments, and tiny corrections hidden behind every beautiful detail. That's what really turned this building into a world-famous landmark. When people look at Burj Al Arab today, they see luxury. They see the sail-shaped design, the gold, the marble, and the incredible views. But after learning how it was built, I don't think those are the most impressive parts anymore. What really stands out is everything that had to happen before anyone could even start building the hotel. There was no island, no solid rock close enough to build on. They had to create the land, drive 230 concrete piles into the seabed, pour around 70,000 cubic meters of concrete, assemble about 9,000 tons of structural steel, and build a tower that rises 321 meters above the Gulf. Even the helipad, sitting 210 meters in the air, became possible only because thousands of small steps were done right. It took 5 years, around 2,000 workers, and countless decisions that most people will never notice. Long before Dubai became known for its skyline, Burj Al Arab became the symbol that told the world what the city wanted to become. If there's one lesson I take from this story, it's that the biggest achievements rarely happen because of one brilliant idea. They happen because thousands of small details are done with patience, precision, and consistency. If you enjoy stories about incredible engineering, impossible construction projects, and the ideas that change the world, make sure to subscribe and join us for the next one.